10, it's Miss OD again. So now we've had 3 lessons looking at all the different rules that we can use with exponents. We're going to put them into a little bit of practice solving some exponential equations. Now sometimes we can solve these exponential equations without a calculator. However, there are on other occasions where you must use a calculator. Today we're just focusing on non-calculator ones. So all of these equations have to be solved without a calculator. So what we're going to use is our knowledge of equations and our knowledge of equivalence. If I have 3 to the power of 2 is the same as 3 to the power of x, my bases are the same. They are equal. It tells me here that they're equal. That must mean that then our exponents have to be equal. That's the only way that the two things can be the same. So it means that x has to be equal to 2 for that to be a true statement. We're using this simple idea to help us solve exponential equations. The key rule here is the bases have to be the same. If they are not the same, then the technique that we use today will not work, and then we'll need to use a different method another day. All right, let's start simple and we'll get harder as we go along. 5 to the power of x equals 25. So the key here is you need to have the same base on both sides. We can't break 5 up any other way. It's a prime number, so it only has 1 and 5 as its factors. We can rewrite the 25. We do know that 5 squared is 25. These two things are the same. Now, because the bases are the same, we can immediately say x has to be equal to 2. That's the only way this statement can be true. So that was quite an easy one. Let's get a little bit trickier. Here we've got 2 to the x plus 1, so we've got a bit more in our power this time, equals 16. 2 cannot be changed. It's a prime number. So it only has 1 and 2 as its factors. So we can't really do anything with the 2, so that has to be there. A little tip, if your base is a prime number, that probably tells you what you need to have the base to be on both sides. Luckily enough, 16 can be written as 2 to the power of 4, because 2 times 2 is 4, times 2 again is 8, times 2 again is 16. So now we have an equivalent statement. That must mean this power, they are both to base 2, must be equal to that power. So we have a very simple equation to solve now. It means that x plus 1 must be equal to 4. And then if we just do simple equation solving, it's plus 1, so I subtract 1 from both sides. And so then obviously x has to equal 3. It doesn't matter how complex this equation could get, the process is exactly the same. Get the same base, make the powers equivalent, and solve a simple equation. Let's try some more. Okay, 2 to the power of x equals 1/2. Now when we're using this process, we must have the equation without fractions. So that means we need to change this somehow. Luckily we have a rule, and we have this rule. If I just quickly write our negative power rule, I know this is the case. This is our rule. Remember, the 2 here is to the power of 1. So using this rule in reverse, I'm going this way. I've got something in this form. I want to this time write it with a negative power. So the rule says the base stays the same. So it's 2 in the base. And then what we do, whatever the power is, just make it negative. So in this case, make it -1. Now it becomes a super easy question. For these two statements to be true, for them to be equal, the powers have to be the same. So x must equal -1. That's simple. Let's try another one. So same idea. The 3 is a prime number. We can't change the 3, so that's probably going to have to stay there. The 27, if we have that 1 over, the 27 is the same as 3 cubed. Now, if we change this using our negative power rule here, the rule says keep the base the same and just make the power negative. So that must be 1 over 27 is the same as 3 to the -3. Now we work on solving it. Again, for these two things to be equal, because the bases are the same, the powers must be equal. And again, we have then a simple equation to solve. It's -1, so we do the opposite. We add 1 to both sides. So we have x equals -3 plus 1 is -2. So you can see that's definitely not obvious from the beginning of the question. So it's important to go through that process. Okay, now we get a little bit trickier. This one is a little bit deceiving because you think, oh, well, 8 is just 2 times 4. But remember, the thing is, they both need to be powers. So this is not 4 to the power of 2. It's not 2 to the power of 4. So we need to be able to write both of these numbers. So in this case, we have to change the 4 and the 8. So here, remember, the 4 is same as 2 times 2. And here, the 8 is the same as 2 times 2 times 2. So we can write both of them as powers of 2. I'm going to put it in brackets to start with. So 2 squared is the same as 4. That's still to the power of x minus 2 from here. I'll do the same with the 8. The 8 is the same as 2 cubed. They are the same. And that is to the power of x. Now this is where we need to use another power rule, the one about the power inside and the power outside. When there's a power inside the bracket and a power outside, we multiply those powers. Now be careful here, you need to make sure you multiply everything. So you have to do 2 times x and 2 times minus 2. So take care with that. So I get 2 times x is 2x, 2 times -2 is minus 4. Equals, do the same thing with the right hand side. We just multiply the powers, so it's 2 to the 3x. Again, these two things are equivalent. They are both to the base 2, so the only way they can be the same is if the exponents are equal. So that means 2x minus 4 must equal 3x. Then we just do some simple equation solving. This time I'm going to actually subtract 2x because I want to get my x's on the same side. So when I do that, I'm going to have -4 on the left, and I'll have 3x minus 2x is x, positive x. Of course, you could have added 4 and then subtracted 3, and then you would have had to have multiplied or divided by a -1. So that was just a quicker option. Okay, so again, you see, not so obvious to begin with. So it's important to go through at least some of these steps. All right, let's look at number 6. We have a half and we have a 4. So again, we need to write them as powers of something. This is 2 to the power of 1. We know 4 is 2 squared. So here is our key. We want base 2. So I changed using my negative power rule. I changed this to 2 to the power of -1. That's the same as a half. That's still to the power of x. I'm going to change the 4 to 2 squared. Now I use my power inside, power outside rule. So -1 times x is minus x. And that's still 2 squared. So now the powers must be equal. So I say minus x equals 2. Whenever we solve an equation with x or whatever the letter might be, we should always have it so the letter ends up being positive. So in this case, I'm going to multiply both sides by -1. And so then I get x is equal to -2. Okay, so a little bit harder than the first couple. And then one more. This is probably the hardest type that you would get. Again, you cannot write 4 as a power of 8. You cannot write 8 as a power of 4. Remember, we have 4 to the power of 0. Anything to the power of 0 is 1. 4 to the power of 1 is 4. 4 to the power of 2 is 16, not 8. So be careful there. So you cannot change this or this to be either 4 or 8. This means you need to change them both. So 2 is the option, and the more you do of these equations, the more easily you'll see what to change the bases. So let's change that quarter first of all. I know 4 can be written as 2 squared. That's all to the power of 1 minus x. I know 8 can be written as 2 cubed. Now here, I'm still dealing with inside the bracket. I'm going to use my negative power rule, so I don't have a fraction. So the negative power rule says keep the base the same and just make the power negative. That's still to the power of 1 minus x, and that of course stays as 2 cubed. Now we're going to use the power inside and outside rule. Again, don't forget you must multiply both parts of that exponent there. So I will have minus 2 times 1 is minus 2, and be careful of your signs here. Minus 2 times minus x becomes positive 2x. And that, of course, equals 2 cubed. And then we'll make a simple equation to solve. The powers must be equal, so minus 2 plus 2x has to equal 3. Solve your simple equation. I'm going to add 2 to both sides. So I get 2x equals 5. And then I'm going to finally divide by 2. And so therefore x equals 5 over 2. Or of course you can write that as 2.5, 2.5. They're all the same. So that's probably the hardest that you'll get. As I said, the key, always get the basis of saying that has to what happened first. A lot of the time, if you choose prime numbers as your base, that will make it easier. It doesn't have to happen 100% of the time, but a lot of the time, that's the easiest option. Okay, go and have a try by yourselves. Good luck.